Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Kini bin Muhammad Noor, and today I will be explaining chapter 1, random variable calculation. Here we can see the table, number of resistors that are defected, X, and the probability of a resistor being defected. From the probability distribution function, the number of resistors that defected is selected. Here we are trying to find the value of mean, variance, and standard variation by using the random discrete random variable. The first step will be trying to find mean, where u equals to ex, and we get the value of u is 3.74. The second step will be trying to find ex squared, where we get the value ex squared equals to 17.68. On step 3, we'll try to find the variance, where we use the formula ex squared minus ex squared, where ex squared equals to 17.68 and ex equals to 3.74, where then we square it up, where we get variance equals to 3.69. On the fourth step, we'll try to find the standard variation, where we use the formula square root of variance, where variance is 3.69 and where we get the standard deviation 1.92. For normal distribution calculation, over 30 resistors that are being tested in Kayama Home Industries, we are following each list value of rated resistance during the test process. There are 10 values of resistance with each defected amount are selected as data below, where you are given a table value of resistors and number of resistors that are defected. Given that the mean is 3.74 and the standard deviation is 1.92, we are trying to find the approximate probability of A at least 6 resistors that are defective and B between 2 and 6 resistors that are defective. Step 1, in the normal distribution table, the random variable which the number of resistors that are defective is written as x and 3.74 1.92 squared, where the value mean is 3.74, value of variance is 1.92 squared, and the value of standard deviation is 1.92. On step 2, we will calculate the probability that at least 6 resistors are defective by using the formula for the standard normal distribution, which is P z equals to x minus u divided by sigma, where we get P z is bigger or equal to 6 minus 3.74 divided by 1.92, where we get 1.18. Then we get P z is higher than 1.18, and by using the probability normal distribution table, we get the value 0.118. Therefore, the probability that at least 6 resistors are defective is 0.1190. On step 3, we will calculate the approximate probability that between 2 and 6 resistors are defective by using a formula for standard normal distribution, which is the probability equals to z equals to x minus u divided by sigma, where the probability 2 is lower than z, but and z is lower than 6, and we get p 2 minus 3.74 divided by 1.92, where we get minus 0.91, and 6 minus 3.74 divided by 1.92, where we get 1.18. Then we will rewrite it to so that we get 1 minus p z is bigger than 0.91 and minus p z is bigger than 1.18. And then using the probability table, we will turn it into 1 minus 0.1814 minus 0.1190, where we get 0.6996. Therefore, the approximate probability that between 2 and 6 resistors are defective is 0.6996.
For sampling distribution calculation, the case study is at the Kayama company. The mean amount of defected 50 milliohm resistors is 6 resistors and the standard deviation is 2. A random sample of 30 resistors is drawn. What is that probability? The average amount of defected 50 milliohm resistor is greater than 7. The solution is first step to find the mean for the sample. Mean, for example, mu x bar is equal to the mean of the population is equal to 6. From the question, you get the mean population is 6. Okay, next step 2, to find the standard deviation. This formula, standard deviation x bar is equal to standard deviation population over set n is derivative from the variance formula. So, by the information from the question, the standard deviation population is 2 and the sample size is 30. So 2 divided by set 30 is equal to 0.37. Step 3 is to write the sample mean distribution, normal distribution for the sample mean. X bar sample distribution is a normal distributed. So the mean for sample distribution is 6, and the standard deviation is 0.37 square because we put here variance. For the next step, step 4 is to find the probability. From the question, it asks what is that probability the average amount of defected 50 milliohm resistor is greater than 7. So P X is more than 7. So we need to use Z distribution formula. So Z design for greater than, just use from the original equation. P X bar greater than 7. So Z is greater than S bar minus mean divided by standard deviation. So PZ is greater than 7 minus by 6 divided by 0.37. So we get PZ greater than 2.7. From the table or we using calculator, we can get the answer 0.00347.
Assalamualaikum and good morning. So my name is Muhammad Naim, and so for my section, which is estimation calculation. So the question is, suppose that 30 samples of resistor are being tested by Kayama Home Industry. During the testing process, there are defected resistor R has been identified. So the average is 3.74 resistor, and the standard deviation is 1.92 R. Construct 95% confidence interval for population mean. Okay, so the solution for the question. Step 1, in estimation function, the sample mean S bar has normal distribution of random variable, which is the number of resistor that defected is written as S bar. Estimation n 3.74 of mean and 1.92 for variance over 30, which is sample. Which is the value mean is 3.74, variance is 1.92 square, and standard deviation is 1.92, and n equal to 30. Okay, step 2, we need to come out all the given information, which is we know n equal to 30, x bar equal to 3.74, standard deviation is 1.92, alpha which is 1 minus to 0.97, 0.95. So the answer is 0.05, and the z value, which is z 0.05 of alpha divided by 2, so we get 0.025. Therefore, by referring the percentage point of the normal distribution table, we get the z of 0.025 is 1.96. Okay, continue for the solution. So, by using the formula for confidence interval mean population is given by S bar plus minus Z alpha over 2 and multiplied by variance and standard deviation over square root of n. So, therefore, we substitute all the given information into the equation above. So, we get 3.74 plus minus z 0.05 over 2 multiplied by 1.92 of standard deviation over square root of 30, which is 30 sample. And we get the final answer mean population, which is range between 3.053 and 4.427. So thus based on the sample data, a range of population mean of the number of resistors that defected during testing process is between 3.053 and 4.427.
Talking about the hypothesis calculations, hypothesis testing calculation. So the question that we settled on was Kamaya company claims that their average defective resistor is less than 3. So let's just say Raj feels like this is wrong and he wants to investigate. So he set the significant level to a 0.05 and to see if it's less than 3 or more than 3 or equals to 3. Has like different values of resistors. So what he does, he collects 30 resistors with different values of resistance, and we see how much their defective production is. So this is the table that shows the numbers. Step is to find the hypothesis. So the null hypothesis is the mean production of defective resistor is 3, and then our alternative hypothesis is the mean production of defective resistors is not 3. So we find that the sample mean, and you can see the mean is like the total number of defective resistors divided by the number of resistors that we collected, which should be 30. So the average falls upon 4.53. See that we calculate standard deviation with the given formula, and it reads 1.714, and then the variance is 2.938. So would be finding the Z critical, right? Z score to get the critical value, and the calculation we've done, it shows that the critical value is 1.699. We will do calculation for Z test score and to see whether we can accept or reject the null hypothesis. So with the calculations, we can see that we get 4.8892, which is more than critical value, so it falls in like the reject zone. So now we have to reject the null hypothesis because there is how to say enough evidence to support that the claim mean production of defective resistor is less than 3 in that company.
So I will explain about linear regression calculation. So the table we got here is the value of resistor equals to X. The number of resistor that defect is the X value. So next, let's move to the next part. So from that, we create a table of X and Y, and also X multiplied by Y, and X power 2 and Y power 2, and then we sum all of it. So for X, sum of X power multiply with Y, we got 1898, and also sum of x power 2, we got 45,255, and sum of y power 2, we got 140. We find the SXY. So for the calculation, we must sum of xy minus 1 over n there with sum of x and also sum of y, and then we got the total of SXY equals to 1237. And step 2, we find the SXX. So the formula is sum of x power 2 minus 1 over n, and we power 2 is sum of x. So we got 690.97. So for the step 3, we find SYY. So the formula is total of y power 2 minus 1 over n, and the sum of y power 2. So we got 110. And for the step 4, we find the beta bar 1. So the formula is SXY over SXX. So we got 0.04031. Next step, we find beta bar 0. So formula is y bar minus beta 1 x bar. So we got 0.3355. And the next part, we find the y bar. So beta bar 0 plus beta bar 1 with x. So we sum up it. The next part is we find x when we find y bar when x equals to 85 milliohm. So we got y bar is equals to 3.76, and we find SSE. So the formula is SYY minus beta bar 1 SXY. So the value of SSE equals to 60.36. So the step 9 is we find MSE. So MSE, the formula is SSE over n minus 2. So the value of MSE equals to 2.156. And step 10, we find R power 2, and the value of R power 2 is 0.4512. And the last step, we find R. So for the formula R is SXY over SXX with SYY. So for R equals to 2.1287. That's all from me. Thank you.